A very good evening to all of you. On behalf of IES chapter of IEEE student branch of Sri Lanka Technological Campus, I would like to welcome you all to the second day of the webinar series of ARDIOFLO. Also, it's my pleasure to welcome the newly registrants who are participating with us today. Then I would like to extend my special welcome to our facilitator, Mr. Dinushan Prabashitha, an automation engineer of MAS-KREEDA. As usual, before starting the session, there are a few announcements regarding today's workshop. We request you all to rename your Zoom meeting name with the name that you used for the registration. Also, just like the last week, we will send you the attendance sheet and feedback form in last 30 minutes. If you have any ideas regarding the session, please don't hesitate to fill the feedback form for the improvement of our workshop. We will send you the answers for the last week homework through emails. If you have any doubts during the session, you can send a message to the WhatsApp group or comment during Facebook Live as Zoom chat has been closed due to the inconveniences that will occur during the session. And those questions will be discussed during the Q&A discussion. So we hope that you would be consider all those statements for a fruitful session of ARDIOFLO. So now I cordially invite our facilitator, Mr. Dinushan Prabashitha, to conduct today's session from now onwards.
Okay, good evening all. Today let's start what we left over in the previous session. So I'm going to recall some of parts because there are newcomers, I think. Do you hear me, Divanta?
Yes, sir, we can hear you.
Okay. I will share the presentation. Give me some time. Here we have stopped here, I think. Can you hear me? Can you see the presentation, Divanta?
Yes, sir, we can see.
Divanta?
Yes, sir.
Okay.
Hello.
Can you hear me?
Of course, sir, we can hear you.
Okay. We discussed about the control structures in the Arduino in the last session. So I'm going to start from here. We talk about the break, I think, and go to control structure and switch case. We did these control structures and I didn't give the homework last week. This one display 1 to 1000 in a serial mode using any loop. The Proteus, because there are newcomers, I think. So I will show how to set up Proteus and VSP in your computer. Okay. I think you all have installed the VSP admin virtual serial port emulator because we need to emulate a serial port because we are working on the simulated device. So we need to configure a port for that simulated device. So you need to create a new device. Here you can create a new device. and select the connector, and next, and you can select any COM port you need, and select COM port 2, 3, finish. Then you can see here the connector is ready for you. I think this is easy setup. Now you can see when you go to Arduino, you can see here tools, port. Here you can see the port you have created. Here I have created 2 ports, so there is 2 ports here. I will remove one because I only need the 1 port, so I'm going to keep the COM port 1. In the previous sessions, I have mentioned you all how to select the COM port 10, the board that you having. Here, when you go to tools, you can see the board. Here you can select the board whatever you are having, so you can connect it to a PC. So we last week also we are trialing with the Arduino Uno, so I have selected Arduino Uno, and also the port is COM port 1, and the basic things you can see the actually if you print some serial values, you can see in the serial monitor which shows the output to you. Okay, and yeah, that's okay for now. Let's configure Proteus software with the Arduino in order to simulate something. So I'm going to print some variables in the serial monitor and simulate it on the Proteus. So let's begin. I'll open my Proteus. Select a new project here. You can give a name here, any name. Then next, keep the defaults itself. Do not change any settings here. Okay, now you can see the schematic we have received. So let's insert Arduino. We are using here the Arduino Uno. Yeah, can keep Arduino Uno. And then we need serial monitor. I mean, here we have to simulate. So I'm going to get a serial monitor here, the virtual terminal. This will act as the serial monitor for the simulation. Ivanta?
Yes, sir. Yes, sir.
Can you hear me and see the presentation? And
Yes, sir,
Yes,
we
sir.
can hear you.
okay. Here, this virtual terminal will act as the serial monitor for the simulation. Okay, and we should insert the COM port. You have to type COMPIM. That means COM port physical interface model. In order to simulate the communication port, so you need to connect this RxD to RxD here and TX to here TX, and here we have to change the connections. That means interchange the RX and TX pins. Here RX connected to TX and TX connected to RX, because it's going to act as a slave for this Arduino board. So we should connect the terminals interchanging RX and TX. So then I'm going to code this one with the serial port. Then we can see whether there is output or not. So I'm going to get some example. Okay, here is my Arduino program. Okay. Dimant, can you see these letters in the Arduino?
Yes, we can see.
Okay. Okay, here I'm going to initialize the serial communication. Begin and 9600. Sorry, I'm going to save it first. Okay. Now I'm going to print something here. Dot. I'm going to compile this one. Here we have to export compile. We have to go to sketch, then export to compile library, compiled by binary. So before that you need to save it. I'm going to save it in as example one. Okay, then it will compile and save as a binary file in the example one folder. It's compiling. Okay, then we need to add. Sorry, before that we need to configure this virtual monitor. Double click on 10. You have to see the baud rate. Here we have set the baud rate in the Arduino example. Here 9600. This should equal to this one, and also in the communication port also there should be physical baud rate should be 9600 and virtual baud rate should be 9600 because we are using baud rate for Arduino 9600. Okay, then you have to double click on it, and in here when we double click Arduino board, we can see we should upload that compiled binary. So we have to select SLTC and example one. Here you can see the compiled binary. That is in the format of X file. Right. Okay. Then you can simulate this one. Here you can see the it's emitting test code for serial communication. That means this is coming through the serial port of the Arduino. So we can read in the terminal monitor this code. So I think all of you have this knowledge because we need this knowledge to carry out other examples in the future. So you need to practice this one because we are doing the simulations with the Proteus software. Okay, I am going to stop the Proteus for now. Then we can go back to our practical session. Okay, here the control structure we have done in the previous session. Here the switch case. We can switch any case according to the variable we have assigned. If you assign here, you can see in the example, I have assigned case number. That means I have defined integer variable case number, and I have assigned 0 for the case number. When you execute this one, it will only show the case number 0. That means here we have defined only case 1, case 2, and default. So it will return the default value because it will not. This is the basic idea of the switch case. We have discussed and practiced this one in the last session. Okay, this is a homework for you. Can you write down this one or note down? Otherwise, you can share it also. Dimantha, can we share this one also? Dimantha?
Yes, we will share it, sir.
Yes, sir. Yes, sir. We can.
Okay. Here today I'm going to talk about the Arduino analog signals. Here the syntax for the analog signals. Here only the writing and reading. Analog read and write. That means if you want to read the analog signal from the Arduino board, you need to type this like this analog read. And if you want to write to a analog pin or a PWM pin, you can write analog write, this one. Here we have to define pin and a value. Pin means the pin you are going to work in with, and the value is 0 to 255. That means 8-bit value you can add to that position. And here the analog output set pins are variable voltage level. Okay, that means the analog output set the pins variable voltage level between 0 and 5 volt. That means if you set a value to analog write code, then it will emit analog voltage. That means you can vary between 0 voltage to 5 voltage, because actually Arduino working on 5 volt voltage 5. That means volt 5. You can vary that voltage between 0 and 5 using the analog write function. Next, we can try this one in this example. Okay, let's do this one. Yeah, I have written this one. Analog write. Okay, I think you all can see this one, and you have to note it.
So we can't see the screen. It just went out.
Can you hear me?
Yeah, we can hear you, but we can't see the screen, sir.
Okay, sorry. I think there are connection issues.
Yeah, we can hear. We can see it now.
Now, okay, I think. Okay. Yeah. Now, can you try this one in your laptops?
Okay.
Sorry, forget this one. Only need this one. Only the need. I need only to view that terminal window, because it will print the analog values I 0 to 255. Okay, I will. Yes. Don't confuse about this one. This is the same example I have used in the previous session. So I'm going to upload this one to this one. Upload this Arduino port to, you have to follow sketch export to compile library. Then tolerate this one and analog, right? Debug, reset the debug. If you didn't see any windows here, when you run the simulation, if you didn't see any window here, you have to reset the debug pop-up windows here. Yes, then you have to run the simulation again. Here you can see analog values increase in 0 to 255. Then again it will reset to 0 and again it will increase to 0 to 255. Here you can see how it's going to work. This is the for loop. Then it will increment one by one, and it will write to this LED pin. That means analog pin the value of 5. Then it will emit the voltage according to that value in the eye. Actually, here we can get the varying voltages, so we can dim the LED. That means you can have the several brightness levels in your LEDs. So you can make some things like dimmers and like night rider circuits like that. You can make by using the analog drive. Okay, I think you have finished this one. Dimantha, can you see and hear? I think there is connection issues.
Yeah, little bit.
Yes, sir.
We
Dimantha?
couldn't.
Yes, sir. We can hear, but the voice is not much clear.
Okay, now is it
No,
retro?
yeah, now it's good.
Okay, let me know if there is any issues.
Okay.
Yeah. Okay, let's move on to the other slide. Here, when we talking about analog signals, we have to talk about the PWM signals also. Either I think you have learned about the pulse width modulation in Arduino. Here we can actually make a signal with a specific pulse width to generate a specific analog signal. That means analog output from your Arduino board. So you can take analog value from that output pin. This is actually doing by oscillating in a high frequency. That means if you want to get the value, here you can see analog write 64. This is the 25% of the duty cycle. That means you can get the 25% from the 5 volt signal. Here the zero. Analog write zero means you can get zero voltage from the pin. Dimantha, can you hear me? Again, I think there is a connection. Sorry for that.
Yeah, we can hear you now clearly, sir.
Okay. Here you can see the analog write 127. If you write this one, you can get 50% from the duty cycle. That means 100% mean there should be 5 volt out from that pin. So if you write the analog write 127, you can get the voltage out 50% from the 5 volt. That means 2.5 volts we can get. And here, if you write the analog write 191, you can get 75% from the 5 volt signal. You can see how the voltage varies according to the duty cycle value. That means if you write analog write and the value, it will give out the
Sir, hello.
Last part wasn't clear, sir.
value corresponding to that value. Okay.
Sir, that part wasn't clear.
Okay. Yes.
Now okay.
Because of the connection now,
Thanks.
Yes, sir, connection.
I think is there any connection is uh, uh, that means the connection issues, right?
Yeah.
Yes, sir.
Sorry for that. I think then first give me 2 minutes.
Okay, sir.
There is a network issue with the facilitator, so we are sorry for this inconvenience.
Can you hear me, Dimanta, now?
Yes, sir, we can hear.
Sorry for the connection issues that I am having. Um, Sorry for that. So let's start again. So, okay, what we are having, we have done. Yeah, the PWM signals, no? So I'm going to share it. Here, we are in the PWM pins in the Arduino. Uh, I think you didn't hear the last things that I have said. Is that correct?
If it will be good, sir, if you repeat the last part
Okay,
a bit. Yeah.
I will repeat this PWM pins in Arduino. Here, actually, the PWM pins, that means PWM pins which can emit the analog signal. That means we can set that pin that is a digital pins, but we can digitally write that pins to become a analog pin, like the analog pin. So here the actually this is the theory part of the PWM pins. I'm not going to teach here the what is PWM and what it can do. So you need to refer the notes and I think teaching materials that lecturers given. So here you can see, I'll explain a little bit. Here you can see the duty cycle. That means we have done previously the thing. Here the you can see here that I have given an example previously. Here the analog write. This is only a write. This is going to write into an analog pin. So it is a no problem here. So when we are going to write the analog value to a digital pin, that become a PWM pin. So if you need to get voltage, that means between 0 and 5 you can write PWM uh, PWM code, that means analog write code in the Arduino. So you can get any value between 0 and 5 volt that corresponding pin. So if you need the 0 voltage, so you don't need the 0 voltage. If you need a 50% from the 5 volt, that means 2.5 volt. So you have to write like analog write 127. If you need the 75% from the 5 volt, you need to write analog write 191. Likewise, actually 0 to 255, that means 8-bit value. So you can vary the voltage 0 to 5 according to the 0 to 255 value. I think you can understand what I'm telling here. So I'm going to move into the next slide. Here you can see the how PWM pins in Arduino works. This is extra theory. If you need this one, you can note it down. We will share this one actually. So no need to add this one now. So let's move on. Let's talk about timers now. What are the timers in the Arduino? These are the two examples for the Arduino timers. Here millis and micros. Millis function returns the value in milliseconds and the micros function will return the time in microseconds. We can do a small example and print the time in the serial monitor. So we can see it in the terminal window in the Proteus. So let's do it. Millis is small example. You can demonstrate this one in the Proteus. Devanta, can you see now?
Yes, sir, we can see.
The latest is that small
Yeah,
enough?
no, it's clear.
Shall I large? Okay. Okay. I think you all noted down. So this is a small one. I'm going to export the compiled binary to Proteus. My Proteus is crashing. Sorry for that. Still, the problem is not solved, I think. Okay, I'm going to upload the code here. Millis. Okay. Then I'm going to run it. Here you can see no window here. You have to go to debug and reset the debug windows. Then you need to run the simulation again. Here you can see the simulation. I will explain the code in the Millis. Here you can see it will print the time of the execution of that function. Here the how many milliseconds did loop have run. So you can print this one after each and every 1 second. Here the delay 1000 mean 1 second. 1000 milliseconds mean 1 second. Delay going to print set as in milliseconds. So you need to set this one in milliseconds. And here the millis function. In the loop function, I have set this one. It's again crashing my Proteus. Debug and reset the pop-up windows. You can see the time. I will stop here. Here the millis. Here you can see the millis function in the loop. You can actually get the value of the time which loop function start. How many that means how much time they spend in this loop function. You can get by using this millis function. So you can print this one anywhere. If you need to get like you think that if you need to get the time between two inputs, I mean digital read. If you're setting a pin, that means I am setting pin number 2 as high. Sorry, if you setting this is read. So I'm going to assign integer variable, that means variable 1 as the digital pin number 2 in the Arduino, and then I'm going to read the pin ITPR2 digital read number 3. You cannot set like this because you didn't initialize the pins, so you need to initialize the pins. Previous session I have taught you about this how to initialize the pins using pin mode. Pin mode should be input and the other one pin mode in 3 input. That should be also input. We are going to measure the time difference between these two inputs. When input 2 occurs, after actually after how many times, how much time taken to occur the pin 3. Can you hear me? Oh,
Yes, sir, we can hear.
okay. Okay, let's do it. We are going to calculate the time difference between the two inputs. I'm going to write this one in the loop function. Here the two pins have initialized. Actually, we can directly put this one in here, but the professional way of doing this one is you have to assign a variable to these pins. I will assign pin 1 to the pin 2, this variable for the pin 2, and another variable for the pin 3. That will be these two. So you can remove this one, pin 1, and here you can pin 3. And actually this one also pin 1 and pin 2. So I think you can see this one. Better note down this one. So I'm going to continue with this example. And get the time when this one going to high. That means this pin 1, when pin 1 is going to high, write the value of this timer. Okay. If that means this pin means the variable 1, so R1, if the var1 equal to high, that means you're going to write the variable. If the variable 1 going to high, time, note down the time. You need to assign two variables like time for first input, sorry, for first input, first two, sorry, this should be unsigned long because we cannot assign int for the timer function. So we have to assign unsigned long for the timer function value. So here going to set it for 0 for now, and then again we have to time for here second input. You can see this one. I think you all can see this one. And then you have assigned the two variables for the timer. That means when first pin going to high, then the timer input value be say in this variable. So we are going to save the timer value when the digital pin 1 goes to high. Sorry. Time. Here we have defined time equal millis. Means when this one happens, what is the time in milliseconds? Then again we can if the variable 2 is high. Then we can say this one equal to time. Here you can get two different values, because the variable one will here the time for first input variable is stores one value, and time for two input that will store another value, because these two operations will occur in two different times. So we can get finally the difference between the time taken. You can define another variable that is also a time variable. So you have to in variable type time between two inputs, right? Okay, these are the three variables we have to define in the name of time. So okay, then we can write we have to set a condition here, because if these two are 0, then there will be no calculation. So if this variable should not equal to 0 and function. These are the things that I have done in the previous session. So I think you all know these ones, and I'm going to consider the other variable. This one, this should also not equal to 0. Then it will calculate the difference time between the two inputs. Devant, I will ask some question from you.
Okay, sir. Okay.
What is the that mean large variable here? That mean the variable with the large time. That mean the greatest time with the when the loop is running. You think these consider these two variables: time for first input and time for second input.
Yeah.
Which variable has
The first input gonna have the large time. Right.
first one? No, I think, because if we going to press the button first button in first time, then it will have the small value, no?
Oh yeah, yes.
Okay, right. I think you have understand this one. So I'm going to press the first input in first time and the second input at the second time. So we can get the difference like this. So right, okay. I think you all have get this example. You have to run this one in your Proteus example. I will compile for this one for errors. Yes, pin 3 was not. Yes, pin 3. There is no pin 3. Sorry for that. You can see how to debug the code's errors in your code. When you compile in this one, you can see if there is any errors. I'm going to no, don't upload it. You have to compile it. Then again you have to print this one, serial dot print. I'm going to difference, right, and serial dot print. I have explained you about the serial dot print and serial dot print ln, the difference between these two keywords. So I am not going to explain it again. So I'm going to print this one in this one. Okay. Then you can export to compile library. Here the millis. Then you need to design PCB. You have designed some schematic for this example. Here, as you can see, there are two inputs. Here, there are two inputs. That means pin 2, 3. We have assigned two inputs for the pin 2 and pin 1. Pin 3, sorry. So, and we are going to read it digitally. Here, the readings are going to be digital. Okay. Now I'm going to Proteus. Open a new project and rename it as millis because this is with the millis function. Keep the default values as it is. Then insert Arduino. I'm going to do the whole thing in this one. So there are how many inputs? That means here 2 inputs. We have initialized 2
Yes,
inputs.
pin 1 and pin
So
2.
we are going to insert 2 inputs in the Proteus. I'm going to save it because my project always crashing. This one. Okay, push buttons. Now search push button. Here you can see a push button. Then insert it in here. Here I'm going to add 2 push buttons as in my example. Here you can see 2 pins. So pin 1, pin 2. Pin 1 is going to number 2 and pin 2 is going to number 3 and 2 and 3. I'm going to attach this one number 2 and number 3. This is going to become number 3's one and this one going to number 2's. Okay. As you all know, when we are attaching some push button, you have to use a input pull up resistor. That means pull up or pull down resistor in order to cancel out any noises in these input bars. I will explain with some example later. Okay, I will do this one for now. Resistor. You have to take 10K. I think the metal film. You need a metal film. This one. You have to take the 0.6 volt metal film resistor, 10K resistor. Okay, I'm going to take this one and for both using rotate this one and take this one, and you have to join at the end of this push button and here this is going to be a full down resistor because we are connecting this resistor to the ground. If you are connecting this resistor to resistor to 5 volt, then it will be a pull up resistor. Here we need to use a ground. Ground can be found in the terminal modes. Okay, then you are going to input a 5 volt into the Arduino board. So you need to insert high volt. That means 5 volt here. Here power. You can get the power terminal and connect this one here. And then again power. Connect this one here. As you can see, now we have connected the two push buttons here. You need to see the what's going on this Arduino board. So you need to save it because this is going to crash. Signal virtual terminal, get the virtual terminal from this one and keep it anywhere you like, and then you will need COM port. You have to write COMPIM. That means COM port physical interface module. Then you need to connect this RT, RX and TX to the Arduino. Here RX to RX and TX to TX. But in the terminal, you have to connect in the opposite ways. That means that RX should go to the here TX. Here going to you have to connect. Right, that RX to TX, and then this TX to this TX to this RX. Okay, as you can see here, now the whole schematic is completed. Then you need to save this one, and I'm going to export this compile binary to so I'm going to double click here and desktop. Here to find the folder you have written the code. So I have written in release. So good to okay. And I'm going to double click this one and check whether the baud rate is correct, and check this one also. Here change this one to 9600 physical baud rate and virtual baud rate also. Okay, then run the simulation. Okay, now we are running the simulation. Here you can see the previous function. It is going to loop every time because this will loop every time because these codes having the conditions. If the condition satisfies, only this one execute. So you need to push these buttons. As you can see, if variable 1 means var1 means, here you can see digital write pin 1. This one pin 1 connected to Arduino pin 2. Here you can see Okay, you are going to push that Arduino pin 2 button here. This one is the Arduino pin 2. I will edit some functions in the code. I will edit this code because I am needing some output when the button is pressed. I'm going to edit this one. Here is the variable 1. That means we are 1. Digital read pin 1 having a high value. Then it will serial print button 1 pushed. Okay, then again we can set here the button 2 push. Okay, can you all see Dimant, can you see this one?
Yes, sir. Little large letters will be.
Okay, I will enlarge this one.
Okay.
Here, can you see this one?
Yes, sir, we can see.
Okay, I'm having a problem of showing all the parts. Okay, I will scroll down.
Okay, sir.
Dimanta, did you note it down? Or type it in your Arduino IDE?
Last part I couldn't get. All the others I typed.
Okay, well, what is the last part? That means
if time for is input.
That means not
unequal,
equal 0. That one.
Yeah, that one. Yeah.
Okay, I will keep it that way. Did you understand that one?
Yes, sir.
Okay. Okay, now I'm going to check this one on my Proteus. It's going to crash everything.
Excuse me, sir.
Yes.
There is an announcement for the older participants present here. You just have to have the guidance to lead you in the direction until you can do it yourself. How to write a research paper, the process of moving from idea to published manuscript. IEEE Student Branch of SLTC, in collaboration with School of Postgraduate Studies and Research of SLTC, proudly present a webinar to have a proper guidance to an outstanding research paper. Join today at 6:30 p.m. via Zoom. We request all the registrants of the research workshop to log into the meeting at least before 15 minutes to start. We highly appreciate your participation in this valuable session. Thank you.
Okay. I think we can move on to the session, I think.
Yes, sir. We can continue.
Okay, we have coded that one in the Arduino, so I'm going to upload this one into our board. So here, edit component and program files. You can select the hex file and select OK. And you can run simulation. Let's see whether these buttons work or not. This is the as I'm doing this one with you, so I'm going to check whether my code is correct or not also. Here you can see the difference also. Adimanta, did you see that one?
Yes.
difference between two button presses.
Yes. Yeah.
Here, this difference is in milliseconds.
Yes.
Okay. That is the difference between these two button press. That means I pressed the button one. So I'm going to rename this one. You can part difference, part value. This is a push button one. Button one. I will check this one as button one. Yeah, button one, and the one I will set this one as, sorry, it's not going to hit this one here. Button 2, and okay, here you can see I have renamed this one. If you are going to press this one, button one, and again, sorry, it's going to crash. This is the last one, the PS. I think you all have seen this one. That one. Dimantha,
What part, sir?
did you see the simulation?
The very last part we,
That
didn't see, sir.
because this is crashing too much. Sorry for that.
It's fine, sir. It's okay.
Let me check this one.
Okay.
Sorry, this is not the project. Millie's project, I think. I think here you can see the difference. Okay, Dimantha, now it's okay, I think.
Yes. Yeah. Yes, sir.
Okay, okay, I think you all can get this one. If you disable this, if you go to code, if you go to this code, you can disable this delay or reduce the delay. If you disable this delay, actually this two button presses will increase its efficiency. With the delay, it's going to hold all the functions above the delay. So sometimes it will miss the button presses. So you need to remove that one. If you are going to remove remove this one also, because it's going to crash the Proteus all the time, because it will hold the variable for long time. It will do very rapidly. So you need to remove that one. That means serial print line and the delay, because this will serial print the time um, with the execution of the loop function. Here the loop function. So you need to command or delete these two parts. Then you have to export this line binary to hex file. Okay, now I'm going to, let's check what's happened here. Oh, it's going to print time. There should be some error. Where is the time? Here you can see the time. You have to comment this one also, because it's going to yeah, that one crashed. Okay, I'm going to check again and then rerun the simulation. Okay, you can see nothing in the terminal. Button presses, you can see push button 1 and then button 2 pushes, then you can see the difference. Did you see this one? Dimantha,
Yes, sir.
can you see the? Can you see this one?
Yes.
Okay.
Yes, we can see.
Did you understand the difference between the previous code and this code?
Yeah. Yes, sir.
Yeah.
Okay. Then okay. Okay. I will exit this one and move on to the next part. Okay. Stop the simulation. Then we can continue to the presentation. I think you all have get some idea about the timers. Here, the actually millis and micros are same. Both are same, but the difference is micros shows in microseconds, but millis shows in milliseconds. You can actually get the difference between that inputs in microseconds when you using micros. Okay, I think you can do it as a homework. Uh, Another thing that I have to say, I have given some activities in the previous session. From today onwards, we are not going to have that activities like activities. We are giving some homeworks for you to do in your home. So better to do that homeworks because this will help you to practice some examples in the Arduino. So definitely you will understand all the parts in the Arduino by doing that example. Uh, Not only this session, you have to try the examples in the outside by using outside sources. You can search it in the YouTube or some sites are having the tutorials. You have to do that. Then you can get more knowledge about the Arduino. This is not actually the uh, practicals. We have to do these practicals in real because this is a simulation. You have to design a PCB and you have to make that code into a Arduino board, actual Arduino board. Then you have to upload it in the actual Arduino board, and then you have to do it in your in your laboratory or in the home. You have to buy some sensors and other things. You have to connect these sensors to the Arduino. Then you will get some knowledge about the Arduino. So now we can move on to creating functions. This is a special thing in the Arduino because we need to create some functions to do some works uh, separately. So we can call these functions inside any loop or any setup. So let's do this example here. So I'm going to create some function. Here you can see I have some small function here. Here I have created this new function. You can name this one any test function, anything you want. Request define any function you need, any name in any name. Then you can type whatever you need to do it in the function. I'm going to add this one also in the function. Test function. Okay. Right. Okay. Here, when you are calling a function, you can call it in the loop. That means here this in the loop, the code whatever in the loop, it will run continuously. Here the only in the setup, it will run at once. That means only for the one. When we are powering the Arduino board, setup function will run only one time, but in the loop it will run continuously. If you are going to call this function in, I'm going to call this function in the setup function. Yeah. you can call like this. This is the way to call a function in another function. Okay. You need to do this work in the test function in the setup function. So you have to see these two words in the serial monitor when executing the setup function. So I'm going to compile this one. Okay. Then you need to export to compile library binary. Sorry, library binary. Proteus. Okay. What is my function here? Here, new function, here, new function, and it's the expire. Okay. Then you have to simulate this one. You can see in setup function, new function called test function. So you can go to that example. Yeah, as you can see, I have written that one in the setup function. In setup function mean this one in the setup function, but these two are in the test function. So by calling this test function here, we can run these two codes in the setup function. So you can understand. I think Divanta, can actually Divanta?
Yes, sir. Yeah.
Can you make a test function and call it in the setup function?
Yeah.
Did you understand this one?
Yeah, I'm doing it right now, sir.
Okay. Do you need time or shall I continue?
A few 30 seconds, I think, maybe enough.
Okay, I will give you 30 seconds.
I'm done, sir. I'm done.
Okay, I'm going to move to the next one. Here we have created some function. So let's consider function, how to pass the variables to function, how to pass the variable to the function. So let's try this one. This is the example. Sorry, sending variables. This is my example. I'm going to send this variable into the function. Here you can see here, whatever the value is going to insert in, we have to define what is the variable type is going to pass the value. Here we are going to send int variable, that means integer variable. So you need to have variable type integer also here in the test function also. So the variable type should be same, and you have to send this one. Like if you are sending 78 to the test functions, I have defined int variable, so I'm going to send the variable into the function. So it will take here, and this one print the serial monitor the value. Here you can see how I am going to call the function in the setup function. This is the our function, that means custom function. You can change this one as my function. So can you hear, Dimanta? I think another connection issue.
No, we can hear. Sir.
Also, we can hear you.
Okay. Okay. I'm going to change this function as my function and call this my function in this setup function. So I'm going to call this one, and I'm going to send this number 78 into this function, inside this function. So here the number 78 will insert into the value. That means this integer variable value. So it's going to print in the serial printer. So then okay, I'm going to export the compile library. Okay, then I'm going to stop this previous simulation and upload that X file. We're sending variables. Okay. Here you can see inside the test function and value received 78. The functions received the functions have received the value we have sent through the setup function. So you can understand here inside the test function, here the inside test function print and print the value again. I think you all have understand this one, how to pass the variable from uh, setup function to custom defined function. So I think you have understand this one. I'm going to stop this one. Then let's move on to the other slide. Okay, here is a small homework that you can do from the previous knowledge also. I have mentioned about the loops also in the previous session. So you have to create a new function that prints 0 to 100 using the knowledge of loops and break the loop at 50. When the loop is executing, you have to break the loop at 50 using conditional knowledge. You have to break this one and send me the, sorry, do not send, I will send you the answers. You have to do this one as a homework. Dimanta, did you note it down or do you need any time?
No, sir. I got a screenshot.
Okay, let's move. Okay, the today's last part, I think, interrupt. This is actually very special case. We have to use this one in every time in the Arduino when we are using Arduino, because well, we need to use some inputs. We have to get the values of the inputs without interrupting the function. Without, that means not interrupting. Actually, this is a interrupt. So it's going to interrupt the main function. That means main loop. When you are coding in the loop, if you have a code, that means you are going to count 1 to 1000. If you have written an interrupt code, then it will execute the interrupt code without running that loop. That means you cannot actually you cannot even see that interrupt is happen. So it will run actually in the background. This interrupt allows to certain important tasks to happen in the background and are enabled by default. Like syntax, here the syntax is attach interrupt. You can define the parameters like this one. Here digital pin. If you are using an interrupt function, you have to define the pin to interrupt the main loop. So you have to define the pin here. Then ISR means interrupt service routine. That means you have to indicate here the functions you have to going to use when interrupt function call. Then here the mode. Mode means you have to define the pin state. That means if pin is going to low or if pin is going to high, if the pin is going to change, if the pin is going to rising edge, that means rising edge, falling edge. Dimantha, did you learn about signals or Dimantha?
What do you mean, sir?
That means rising edge, falling edge.
No, sir.
I still know. No?
Yeah.
No, sir.
Okay, you will learn. I'm not going to explain this one because definitely you will learn in your future. Rising and falling edge. That means, let me explain something. Here you can see a wave formation. Here, this is going to 0 voltage. That means here the initial state is 5 volt, but the final state is 0. Here this one is going to falling edge. That means it's going to 5 volt to 0. This here to here, this is falling edge. But consider this one. Here 0 volt to 5 volt. Here the signal goes to 0 volt to 0 volt to 5 volt. So this is here to here. This is rising edge. That is the mode in that case. Here you can see rising and falling. Actually, you can detect these two parts in the signal using interrupt, and also you can select this one also. This is the high of that mode, high level. This one high is that in that signal, this is high, and here is the low. You can you can have any state in the signal in the interrupt function. That's why I'm telling that this is important, because you can actually do any project we are using this one. Any project, not any project. I think you can use this one in your project. And this is an example for the interrupt. Okay, I'm not going to set this interrupt in the simulation part, but you can uh, do this one as I mentioned earlier, because you can create a interrupt button also. That means I have mentioned earlier how to create a button and all the things. You can create a button as an interrupt. Then you can here you can set the interrupt pin. That means interrupt pin means interrupt button. You have to create an interrupt button, and then you have to add the LED, and here the state. That means volatile byte. You have to where design a variable like this one, because this going to hold only high and low. This is like boolean. So you have to define a state. Here you have to initialize the pins. LED pin is the output and the interrupt pin is the input. So this is the input interrupt service routine. Here we are going to attach interrupt to the pin number 2. Then blink is our function. That means when the interrupt button is set to change, that means low to high or high to low, any change will occur this interruption. So here initially the LED pin state is low. That means LED state low means LED is going to off. So when the interrupt is happen, here you can see states equal to not state. That means if the state equal low, then it's going to high. If the state is high, then state is going to low. So I think you have understand this one. Here are the practicals I am going to discuss in the next session. I think you got for now all the things I have covered, because these things, these practicals will require all the things I have mentioned in earlier session and this session. So Dimantha, we can do this one in the next one, and I'm going to do some example.
Okay.
Excuse me, sir.
Okay.
Before moving on, we request all of you to mark the attendance sheet and feedback form given in the chat box. It's not necessary to submit the answers for this week's homework, as we will send the answers by Thursday through emails. AudioFlow is one of the biggest initiatives of the year. This will be a remarkable phase of learning Arduino. So there will be a segment called Do You Know through Facebook in order to see new concepts of applications of Arduino. We invite you all to join with us to develop your knowledge further about this advanced topic. Thank you.
As the final example, I'm going to sorry. I think you have print the serial monitor when button press. Print to serial monitor when button press. So we will do this one. I can add different practicals in the next session for the and that means advanced examples in the next session. Here I'm going to print the serial monitor when button press. So let's do it. Uh, take a new, you can take a new one, new Arduino sheet sketch, and then I'm going to use a string. That means define a string variable called my name, and you're going to hold the name as SLTC like this. You can set anything. Then you have to serial picking the serial port, serial dot picking. These are the keywords when we are using Arduino. When you are coding, you can remember this one. I'm going to set serial print. In the setup function, in the setup functions, then you can actually understand where is the code is running when you are actually running the code. You can see by using this prints where is actually the your code is running, or if there is any issues in the code, you can actually locate the issue by using these prints in the setup function. I'm going to, when you are executing in here, you will see in the setup function text. Then you have to define a pin, initialize pin. That means I'm going to here, you have to serial pin something when button is button is pressed. So I'm going to, you can another again define the pin push button. I'm going to attach the push button to number 2 pin number 2. Then okay, here you can involve push button as an input, initialize it as an input. So I'm going to read the value of input. That means this is a digital pin. Number 2 means digital pin. And I'm going to digital read the pin, push button, and here you can read the pin. And I'm going to insert this reading in the Yeah, actually it's going to read int. That means variable one variable reading. You can set this as a reading push button. Then if you can set a condition, if reading is equal to high, that means high, then you can serial print push button pressed. Else, you can set in the else whatever the things you have to do when there is no read. Else you will do print button. Can you see this one? Is it large enough, the letters?
Yes, sir.
we can.
Yeah.
Don't forget to add the semicolon in every phrase. Okay, here the digital push button is reading, and
So
then
we
it's
can't hear
going
you.
Hello,
Sorry?
sir. We can't hear you,
Yes.
sir. Oh, now.
Okay, now.
Yeah.
Now it's
Okay.
yeah.
Okay. Yeah, this one. Okay. Digital read push button. Then this one all the read value, and if the reading value is high, then it's going to print the push button. Else, for another values, this one will print push button not press. So let's try this one. Export compile type. To double click this one and example 2. Okay. Here, sorry, we have opened a different project. We have to open. Okay, I'm going to add a push button in. Where's the one? Here I have added the push button to number 2, so I'm going to add a push button to pin number 2. So you can remember. Here you can set the push button and you have to the ground. As I said before, this should be input pull down. Sorry, this one. Here you need to power it because we are going to have this one as input pull down. Okay. Sorry, this should be go through the resistor. You need to get a resistor. Resistor 0.6 volt, 10K. I'm going to delete this one and enter again the ground and this one. Okay, you can see this one, and I'm going to insert the program example 2. SLTC. This one button not pressed. As you can see, it's printing horizontally, so there should be an error. I think what might be the error? Okay, here you can see print. I have used here only the print. If you are using a print line, then it will automatically enter to the next line. You have to enter the next line. So I'm going to stop this simulation and rerun the compile process. Export to compile like binaries. Then I'm going to insert again into the board. Compile. Okay. Now we can see it will show vertically. So I'm going to press this one. Here you can see when the button is pressed, push button pressed. I think Dimanta, did you got this one?
Yes, sir, we got. Yes.
Okay.
Sir, the voice is not much clear.
Okay. Now,
Still.
I think you all can see, no? I think all can see, no?
Yeah,
You all
we
can
can
see,
see.
no?
Yeah, we can see.
Okay. Okay. Now I think time has come to. I think can we move on to the Q&A session?
Yes, sir, we can.
Okay. If there is any questions, you can ask from me. I will do other practicals in the next session, and it's going to be a only practical session. Okay, Dimant, is that okay? You need to add something.
No, sir, I
No,
think
sir.
it's okay.
Yeah.
It will not contain any theoretical parts that I have mentioned in the previous one and this one. Okay, Dimant.
Okay, sir.
Is that okay?
Yeah. That will be fine, sir.
Yeah, it's totally okay.
Okay. Okay. Is there any question? Give me 1 minute, Dimanta. I will come back.
Okay, sir.
Okay, sir. Please raise hand if you have any doubts.
Yeah, Hassan Sali.
Hello, Hassan, can you hear me?
Yes, sir. Is sir there?
No, sir will give you time when he come back.
Yes, I'm there.
You can ask.
Moreover, this is a suggestion, sir, not rather a question. Like we've experienced that your Proteus being crashed, no, sir.
Yeah.
I guess if you could run that with the administration permission on your laptop, it might not get crashed. Just a suggestion. You might have tried that maybe.
Yes. I think that will be the issue
Run by
because this
admin.
is my office laptop. There is an issue
Ah,
because we
okay,
are
sir.
not given the administrative access.
And one more suggestion also, sir, when if you don't get the virtual screen on Proteus, sir, without resetting the debug, we can get that
Yeah.
by going to the view tab, sir. While running, if the screen is
Right.
not popping up,
Yeah,
we can go to view and get that.
I'm just going to reset it because it's easy for me, but others can do as you say. Did you hear me?
Yeah,
Yeah,
yes, sir. We hear.
yeah.
Sir.
Okay.
Any others got any questions?
Sir,
Yes.
sir, how to change the time from microseconds to milliseconds?
Sorry.
Um,
How to
how
change
change
the
the time from microseconds to
timer?
milliseconds?
That means timer, no?
Yeah.
Yeah, in the timer part. Here you only have to change this one. Here we have used the only millis now. You can use micros to print the microseconds. Okay. Did you get that answer?
Sir, can you explain it again?
You can actually use, here we have used millis now. We can use micros here. So you can get the time in microseconds.
Okay, sir. Okay.
Yeah, correct.
Okay. Okay, any other questions?
So if you're using Arduino board, what resistor do we need to buy as a pull up or pull down resistor?
Pull up, you can buy, actually, if you are going to use Arduino Uno, you can use a 10K resistor. And also it's work for 1K also. With my practical knowledge, I know it's working for 1K also.
Okay, sir. Okay, sir. Thank you.
Okay.
So it doesn't matter if it vary from 1K to 10K in between.
Yeah, that is, I think there is no issue of using 1K to 10K, but need to check with the, actually, if you are going to use some application, what is that? If you need to high precision, if you need the high precision inputs, then you need to use the actually calculated value for that resistor.
Okay, sir. Okay, I got that. Thank you, sir.
Okay. Okay. Is there any questions?
Um,
Excuse me, sir.
Yes.
So when we are working with these Arduino boards, the usual voltage that we give in depends on what kind of a circuit that we need, no, sir?
Sorry?
The voltage, the input voltage that we give into the board, that
Yeah.
depends on what kind of circuit we are building, right, sir?
Inputs, you means the inputs to the input pins.
Sir,
we
I
can
cannot
hear
hear
you.
you.
You mean the inputs? That means the Arduino board inputs pins.
No, sir.
I think
The input power that we are giving into the board, the input voltage.
input voltage to the board.
Yes, sir.
That means the to power the board though.
Yes, sir. To power the board, and Yes, basically to the power the board, it is normally 5 watt nozzle that we give.
No, you can give up to I think 7 point something because it will not crash. That means it will not run the what is that regulator. I think it's the 5 volt regulator there. So you can go input voltage up to 12 volt. I think that regulator supports 12 volt.
And the current should be DC, no, so we cannot use AC.
Yeah.
Or
Yeah, the current should be DC. We cannot use AC.
so and so now if as you said, sir, we can go until 7 watt to 7.5 watts because it doesn't damage the regulator.
Yeah.
Does it make the board a little faster, or doesn't it make any difference on the board, the increase of voltage?
No, I think it will make no difference in with the voltage.
Okay, so and plus, does the board additionally require any more power if we are to build a bigger circuit to it?
Yeah, that is a nice question because that is there when we are doing some projects, we are adding some stepper motors like actuators. I think you all know that one. When you are using that kind of stepper motors, you will require higher currents. So you need to supply the voltage externally. You shouldn't get the voltages from that output pin. So from the Arduino boards, you have to do it as a separate circuit. You should isolate the Arduino board. Did you
Okay,
get
sir.
that?
Yes, sir. So a
Because
separate power module for the Arduino board and the separate additional power that we are given to the circuits, that should be separate.
yeah, that should be separate with the common ground, but there should be a common ground for the two boards.
Okay, sir.
Okay.
We request participants to unmute your mic and ask any doubts from the sir.
Hello, yes.
Yes, you can ask. Anyone? Is there anyone?
Guys, if you didn't understand anything during the lecture, this is the time to ask. So please, if you didn't understand anything, ask our sir.
I think there is no question.
Yes, sir. I think so.
Okay. Shall we find out?
Yeah.
There is 4 minutes left, no? We can wait 4 minutes.
Yeah. Sir, before you go, can you please give us a list of, I mean, the modules you used in Proteus, so we can search it later and add it?
Modules used in that means
Proteus,
you
yeah.
have to
That serial.
try the examples, no?
Yeah.
That means you need to. That means I am using today. Oh, you.
Yeah. The
No.
things you use today, yeah, in Proteus, like the
Yes.
Arduino board and serial monitor, the COM port.
Yes.
And,
What do you need to know that one?
Yeah, a list. I think people might forget that resistor name and
List of.
yeah.
Right. List of. This is the Arduino board. How do I get the list? That means you need these components, I think, no?
Yeah, components, yeah.
This is the, shall I read this?
No, sir, you can, after the session, you can type it and, I mean,
send to
yeah.
Hari. Okay. We'll send. Okay, any questions? Another 2 minutes. You can do this one and try to do these practicals if you can. Then we can do the other things in the next session. But definitely I will do this one in the next session and do some more practicals, because from the next session it will be only practicals. There will be no any explanations about the theoretical parts and some keywords. You can ask problems in the Q&A session. Okay, I think there is no any questions. Okay, Dimant, shall we wind up the session?
Yes, sir, we'll do it.
Okay.
Once again, please make sure to fill the attendance sheet and feedback form given in the chat box. Now, we will remark the end of the second workshop of ARDIOFLO. Before ending, we would like to extend our sincere gratitude to our facilitator, Mr. Dinushan Prabashitha, for your time and effort on us, and also the participants present here today. We will surely meet with our third workshop on 28 November at 4 p.m. Till then, stay safe and have a good night. Thank you.